Hey everybody, welcome to a picotron tutorial. This is going to be a very basic beginner one aimed at people with no experience in picotron, little to no experience in coding. Um, so I'm going to try to keep the level of mathematics relatively simple. I'm going to explain things from the ground up. Like if you didn't pay attention in high school, you should feel right at home. Otherwise, this might be a little bit boring for you. We'll tackle some more complicated stuff some other time. So basically, we're going to be making a pool simulation. To show you our end goal is going to be something like this, where we got a white ball, we got line guides showing where it will go. Hopefully it will be a little more advanced than this, because I'm not really finished. And you can hit the balls around and score them into holes. We're going to be tackling stuff like, eventually, vector physics, vector math, user data optimization in picotron for particles in particular. But this episode we're going to keep things simple and get our framework ready for our pool game to work out. So we're just going to go over some basics of picotron, how to run a program in a window instead of full screen, the three main functions, init, update, and draw, how to clear the screen, draw to the screen, what variables are in code and how to use them, picotron button inputs and how to use them, as well as some sine and cosine, just really what they are and some basics of what we can do with it, and mouse inputs in picotron finally is what we'll close it off with. So we will be able to have sort of like a ship moving around the window, bouncing off the walls, controlled with the mouse. So if you already know about all that, this is probably going to be pretty boring for you, especially as a first episode, but let's get started. You can just right click anywhere on your desktop in picotron and make a new cartridge. I'm going to call it Pool Tutorial, and you have to type .p64. That makes it a cart, like kind of like an exe. I'm not very good with operating systems, but as long as you call it a .p64, then it becomes a cartridge, which is picotron's format for games. If you right click on it and show cart contents, it's actually a folder containing code, Lua files, and sound, tile map, and graphics files called GFX, map, and SFX. And they all come with some by default, which you edit with the included editors. Since we just created a cartridge, I didn't mention it, but in the bottom left of the screen it said loaded cartridge pool tutorial, because when you make one it loads it. And we could head into the graphics editor, new tab, and it will take us to RAM cart. So this is actually important to understand, because when picotron says loaded cartridge, it means it loaded it into RAM. And I have a fancy little app, but you can take a look at your files. There will be, if you're using default picotron and haven't modded it like me, there will be something called drive on your desktop, and you can double click that to go to your files. And in here you have got some folders. It will look like more like this when you start out. Come on, delete them. Holy shit, I found a bug. Oh, okay, I guess that was just really big files. Okay. These are all just things I had stored here for backup. So after you make your little pool thingy, alright, this is actually the root folder, so it should be empty like this. You got app data, desktop, RAM, and system. I made a folder called carts, or maybe that comes by default. But basically when you load a cartridge, it puts it into RAM, cart. And the reason that you need to understand how this works is because when you are editing the cart itself, like let's say you got a Lua file, maybe like a reusable library type thing that you designed in another project. You're like, you have this Lua file for maybe getting mouse controls, or it's full of a bunch of utilities. You're like, I want to copy this over to my new game. So you copy it while the game is running, try and run it, and it's like it's acting like it's not there. It causes a lot of confusion because when you move something into the cart folder, it's not immediately put into RAM. These are completely separate. In order for it to be updated into RAM, you have to either modify the folder in RAM cart, then when you save by pressing Ctrl S, or I think typing save into the terminal, it will save it to the cart. Or you have to put it into the cart folder and right-click load the cartridge to refresh what's in RAM cart. Sometimes I've had experiences where I've lost like important work because of that, so it's just really important to understand the distinction between a cart and RAM and picotron. See lots of questions about it on the Discord. So now that we have a cartridge, we're going to want to head into the code editor. I don't remember what the default icon is. I think it's some brackets or something, but this is a special one made by a lovely dude named Jitanu, probably pronouncing it wrong. Strawberry Source is a custom code editor with little bookmarks for each function. You can also declare them customly and make little groups, so it's just excellent. Though Picotron did recently add support for bookmarks natively in its code browser. I like this one. Thing is, you won't see any differences in how it's actually going to work. You can follow what I'm typing in your native one and it will work just fine. Or if you like this, you can go ahead and Google it. On the Lexalovel BBS page for it, there's a line of code where it says to type default app Lua and then path to strawberry source, just wherever you saved it to on Picotron. Because if you go here, type default app, it will give you how it's supposed to work. So you can tell it default app, you call a command, the file type, so you can like loop, Lua, or maybe a .pal. There's this other one called OKPal, makes .pal files for editing the palette, very useful. Anyways, if you tell it this, and oh wow, you can even use a BBS link, that's interesting, but I think you'll have to have internet connection to use it. You supply the location, so it's like for an example, put in apps tools loop editor. That would be I suppose that's like assuming you made a folder called apps. Anyways, what I typed in was default app Lua carts / tools / strawberry source. So it's pretty sweet if you want to do that. Anyways, to actually get down to business, we are going to have to do the ritual first 3 things of making a picotron, or Pico 8 cartridge, which is putting down the 3 holy functions init, update, and draw. I like to label mine as well, with a comment at the top, even though it doesn't matter. But the main functions have an underscore at the start. This is to keep them from tangling up with anything that you want to call init or update or draw, even though that would be kind of silly copying the main function names. That's the purpose of the underscore. So to call a function in Lua, you have to type function, and then you type the name of it, and then you type parentheses containing the parameters. Parameters are things that you're able to pass into the function when calling it in code. The 3 main functions are automatically called. Init is called once when you start the program. Update is called once every frame, so 60 times a second in Picotron because it runs at 60 FPS full speed. And then draw will also call once a frame until you go over the CPU usage limit. If your CPU usage gets to, I think, 90% of what the CPU is capable of in Picotron, which is like a fake simulated one, pretty slow. I've heard it compared to a Game Boy Advance in terms of power. If your program starts taking too much CPU, draw will start to be called less. It will be called 30 times a second, so every 2 frames, 30 FPS kinda, and your game will look slower. But when doing graphically demanding stuff, sometimes this is necessary to just put up with a 30 FPS game in order to reach the levels of 3D that you want. So init is going to be called once, and it doesn't have any parameters because it's a system function, but when we start writing our own, we'll get deeper into how those work. Basically, what you're going to want to do now is shut up and copy me, and type function underscore update as well, with the brackets, and at the end of each function you have to type end to tell the computer, or the compiler, however it really works, I'm not completely familiar, that the function is from here to here. So we're going to type our last one real quick, and now we're able to get started. So we're going to start with drawing a circle to the screen. Picotron comes with quite a few different functions for drawing stuff like rectangles, lines, circles, pixels, and even some sort of 3D stuff that I don't completely understand, but I'll figure out. What we're going to be focusing on today is circles. We want to make a little ship sort of thing that we can fly around the screen, like a big white ball in pool, like a white ball's father, or maybe his fat grandpa. It's going to be big. So, in order to draw a circle, you type circ or circfill. Circfill draws it filled in, but we don't want that, so we're going to use circ. And this is like calling a function. When it makes it green in the syntax highlighting is what the colors are called. When it makes it green, it means that it's a system function. So we have parameters that we can pass in right here. The parameters that are required are x position, y position, radius, and in brackets. The color is actually optional because if you don't supply a color, it will use the last color used for the last shape or text or whatever it was drawing. At least I think. It's a little bit niche and specific. I don't make use of it, but it's possible. So we're going to supply the middle of the screen. Picotron is 480 by 270 pixels, so divide each of those by 2 and we'll have 240, 135 for the x and y position respectively. And then for a radius, we'll give like 16, get us a nice respectable circle. And color 7 is white. We can take a look at the GFX editor by going over here, double clicking on the file that I apparently stopped explaining halfway through. And we'll be brought to a screen where we can draw stuff. You can declare the size of the sprites. There is technically unlimited space, but not exactly. It's limited, but the limits are gigantic. You'll need to make a big game to come across these limits in sprite space, because you can make as many GFX files as you want. So these are the colors that come with Picotron, and the palette is customizable, but we'll just be using the default palette. If you are on this tab, it will show sort of like ramps and similar colors going upwards in gradients. You may notice there's 5 colors for blue and 5 for green. I mean, there's a turquoise, but it looks good with the blue. So the reason for that, I think, is because with these colors that there's only 3 of, it's more possible to make creative ramps with them. Like for the darkest red, the next darkest color could be a brown, or maybe, yeah, let's do this one. If you keep your eyes on the spot next to the color number where it goes 2 and 20, it looks like it's getting a little darker. It's hue shifting, which is actually pretty satisfying. So these creative ramps can be pretty fun. The lightest one could be pink for sure. And then with the pinks, it's like the skin color one kind of goes with it. Orange is same story, brown goes with it. So yeah, you're able to make like 5 color ramps with most of the default colors, which is pretty neat for a lot of things. I like to include custom palettes in my stuff. Like, we're gonna go over letting you customize stuff like the palette, the screen scale, just to your liking, because it's fun to know how to do stuff like that, and that you can swap it at runtime is quite nice. So over here it shows them in numerical order. 0 is black, 7 is white. Yeah, my whole point, we want to draw a white circle. So I typed in 7, we run, check it out. We have a circle with a radius of 16 pixels, and it's drawing in white at the center of the screen. So that's pretty cool, but you may notice, like, this is a full screen program. How are we supposed to have a little tiny thing that we can stick in our tool tray, just play pool whenever we want? Well, but to do this we have to call window. And if I recall correctly, the attributes have to be in brackets. So let's try saying like width equals 100, height equals 100. Okay, yeah, sweet. So yeah, to change the window size, you have to call the default function window and supply a bunch of parameters for the attributes in brackets, which is unusual, but I don't know, that's just how it is. There's a lot of stuff you can tell a window, like background updates and mouse full screen allowed. I don't remember a lot of them, but they are in the manual. What we're worried about is width and height. We are actually going to want to make a cute little 64 by 64 program. So we're going to say width and height equals 64, both of them, and boom, check it out. We got a little square here, but a problem is that our ship is no longer drawing because we told him to draw at the center of a big screen. So we can change these to 32, 32 for half of 64, and we got him in the center. He's just looking a little big now. So I'll make him smaller. 6 looks weird. Yeah, we'll go with 4. This is a respectable size. So we have a circle now. And that's not too interesting. You know, like let's say we want to move the circle around. It's not too hard. We're just going to want to declare some variables. Variables are like a number that you can store. So here we're taking an x and a y position. So we can say like x equals 32, y equals 32. And if we tell it to draw with x and y, it will draw it at the same place. So we can change these values in order to move the circle. So keep in mind, draw is called every frame. So let's say, what if we said x equals x plus 1 every frame? We redeclare x to say, right now we'll say x equals 32. Next frame, x will be 32, so it'll say x equals 32, 33 plus 1, and it will keep going up by ones every frame. Our little circle, he went off screen because we told the x value to go up. And something a little bit that may be confusing to you if you paid attention in high school about the coordinate system in coding, you may be thinking it's most logical in like a Cartesian coordinate system where it's a grid. You know, this sector right here, x is positive going to the right, y is positive going upwards, x goes negative going to the left, and y goes negative going down. So it would make sense to draw the screen technically as the top right quadrant. So everything is positive, 0, 0 is the bottom left corner. For some reason, it's not like that. It draws with positive coordinates, but the y 0, 0 is in the top left corner. So the x values get higher going to the right, like you would expect. So x0 is in the top left, and then it'll become 2, 3, 4, 5, 6, all the way up to 480 over here. But the y values, they start at 0 in the top left corner, and they get higher as they go down. There's a name for it. I think it's useful for particular types of maybe geometry or something, I'm not sure, but that's just how it works in all types of coding. Y increases as it goes downward. So you're going to want to get used to that if you have the notion of y increases as it goes upwards from the 4 quadrant coordinate planes and geometry and stuff. It's not like that in coding. So like take a look here, if we do y equals y plus 1, it's going to go down, not up. Something else you may be noticing is that our circle is smearing the screen. It's like it's drawing another circle every single frame, and it technically is because we're not clearing the screen. There are certain applications where clearing the screen you might not want to, especially for sort of visual, artsy, code art, or demo scene type applications. You can do some cool stuff with not clearing the screen. But for a video game, most of the time we're going to want to clear it every frame with the system function CLS, clear screen, and you can tell it a background color to use. With nothing, it just uses 0. So now we got the circle goes down without smearing because we cleared the screen. I'm thinking we should actually supply color 1, make it a little chiller, and once we put it in our tool tray, or I mean that's what I like to do, you don't have to, border disappears, and it's like, it blends in with it. You see right here, it's like the felt of the tool table, I just left it blue. So now we've got a circle drawing with some variables, but it's just moving on its own. So we're going to want to actually move it with, let's say, the keyboard to get things started. It will be nice to learn button inputs in picotron. So the way that button inputs work is you call the system command btn for button, or btnp, which is button press. And this is for checking, like stuff will come up, button will, it's like a, it's a kind of function that returns something. When you call it, you sort of call it expecting it to be either true or false, because that's what it's allowed to return. It returns if a button is being pressed. So if the button that you're asking about will supply like 0, I think is one of the arrow keys, we could do this. Print will print to the screen, and if I recall correctly, when it's a true or false value, it's called a boolean. It's just the fancy name for something that's either yes or no, true or false in code. You have to say toString, and this will convert it to something that can be printed. But that's just a little semantics. I mean, you don't have to do this on your own. You could just watch me. It will give you the same amount of understanding, I think. we'll tell it to print at x coordinate 8, y coordinate 8, color 8. It makes it real simple. Color 8 is red. So yeah, it takes the parameters s for string, that's like the words you want it to print. Like a string means letters, words. It's something that can't be operated on with math. It's supposed to be printed in red. It's a data type encoding, and we'll get more into the specifics of that sometime, but it's not exactly important right now, especially since we're using Lua, and we can just, when we declare a variable, we can just tell it whatever it is, and Lua will understand. It's cool like that. So when we print button 0, make sure not to do it before you clear the screen, because it will print it and then clear it away and you won't see it. Alright, so check this out. False. Okay, cool. So it's the left arrow key. We can press it and it's saying it returns 255 actually for some stuff you can do to tell whether or not multiple buttons are being pressed, but I don't particularly understand it because, so right now I'm pressing left. I press left and up, 181. Left and down, also 181. I don't see how that could be useful. If I press left and right, it says false. So like, it's able to, I don't get it. But anyways, it will be useful, it will be fine for our purposes. When Lua, when it sees that 255 or 181 or whatever, it will read it as true. And that's all we really need for our purposes. So let's say, right, so in order to check whether or not a button is being pressed, we need to use something encoding called a conditional, I think. It's basically a if statement. You type if whatever the heck is true, so we can say ptn 0, then end. So it's kind of like a function, and so every frame it will check if this condition is true or false. You want to supply things like booleans because it's gotta be true or false. If you're not doing a boolean, you can do something like, you can say like if x is less than 30. This will produce something like true or false. It will evaluate it, and then if x is less than 30, it will be true. If x is more than 30, it will be false, and that's how it will know whether or not to run the code in here. So we're going to say if button 0, then x is the left arrow, so we'll say x minus equals 1. If we press left, our circle goes to the left. We didn't set anything else up, so it can't move anywhere else. So let's do the rest of the buttons. If statements are also allowed to have other conditionals inside them by typing else if. So when checking if button 0 is pressed, this conditional will only run if this was false. That's kind of why it's phrased else if. It might be kind of hard to wrap your head around the phonetics or semantics or whatever, the grammar of it, but it's really saying like, if this is happening, then do this. If it's not happening, otherwise, do this. So this can only happen if this is not. We're going to say button 1, because let's see, I have a little thingy for remembering where the buttons are. We got 0, 1, 2, 3. Okay, so 1 is right. So we will copy this. I need to explain something also. I typed x minus equals 1 here. This is like saying x equals x minus 1. Like how I was doing in the draw loop here. If you say x equals x minus 1, every frame x will be decremented by 1. This is the exact same thing, except just a sort of shorthand that makes more sense to me, at least, in my head. You're saying x minus equals 1, so it's like subtract 1 from x, and then that's its new value. So now that we have 0 and 1, we can move left to right. It's going pretty sweet. We just need 2 more values. We'll just do some real quick copy and paste laziness with buttons 2 and 3. Need to make sure this one is else if to illustrate my point I'm about to make. And let's see, 2 is up, so it should be subtract, and 3 is down, so it should be plus. Alright, and also we should be modifying y, not x. Okay, so once you get all this plugged in, we're able to move our circle, but all the movements are not able to happen at the same time, since we did everything in else if statements. Only one of them is able to run at a time. As soon as one of them is true, it does the code inside and is done doing that loop. So this is why it's only able to move in a grid like Zelda or like a Tron bike or something. If we were to come in here, put a little end on every one of these, like so, and remove the else so that they're in separate if statements, we're able to move it diagonal, and it's a little bit more fluid. We can move it wherever we want. Let's delete this because it's not important. And so we're able to move around our circle now, but this isn't going to be very useful for pool. Like, the most we could do is like nudge a ball, being real careful about it. Like, this is extremely lame when it comes to pool. So what we're going to want to do is make it more like a spaceship, where it's got a direction that it's pointing. You can press forward and it will sort of go in that direction. You can also press a button and it will do a little boost in that direction, as if it's a ball getting hit by a pool cue. So that is our next goal, and for this we are going to have to understand sine and cosine. So sine and cosine are part of trigonometry that I don't really understand trigonometry too well. I've been trying to study it, but it's actually not too hard to wrap your head around why it's useful for our particular situation, which is drawing circles. So I'm going to make a big old sprite here in the editor to draw on. Let's see, get a nice big brush. And so sine, when you plug values into it, it's sort of confusing actually. I'm not sure how it's possible, but it produces values that smoothly go up and down. It's not like a saw wave where it goes sharply like mountains. Once it reaches the top, it reflects back down. And then same thing. A sine wave decreases in velocity, I guess you could say. The rate that it's changing upwards, it smoothly decreases until it reaches its top point, and then it smoothly increases its amount of change until it gets to the bottom, making what's known as a sine wave. It makes a smooth, wavy pattern, and in synthesizers it produces a interesting sort of smooth sound. Picotron has a pretty sweet music editor. We can go over here to the instruments, and if we press play, okay, so this is the waveform. We can bring it from sine wave all the way to whatever that is. And okay, so a sine wave sounds like this, kind of like a telephone beep. I don't know how to describe it, but it's very smooth. If you start to get some ridges in there and make it a saw wave, sounds not smooth. So yeah, that's what sine waves are about. And cosine, known as cos, in shorthand and abbreviations, is a sine wave but backwards. So it'll be like this, but it goes down first, then up, then down, then up. Okay, trying to line this up is hard. And so relatively, compared to 0, if I'm correct, in real life, the actual output below the line is under 0, above the line is above 0. I could be wrong. But Pico 8 and Picotron, in order for coding simpleness and stuff like size coding to be nice and easy, it is a range of 0 to 1. So for both sine and cosine, the lowest value is 0, the highest value is 1, and it... Wait, is this true? Angles, yes, I'm pretty sure. Angles are represented from 0 to 1 in Picotron, basically, is what's going to be important to know for the next part. So thinking about this, let's say we want to draw a circle going in a circle, because that's what we're going to need for our ship in order to see the direction that it's pointing, so we can know where we're going to go when we press boost or forward. We're going to have to need something in front of it. I like to use a circle. I suppose you could do like a line or a triangle if you're feeling crazy. But how are we going to draw a circle that's able to go left or right around this hug in the parent circle? Well, if you try to think about it, actually combining a sine and a cosine wave, using one for x and the other for y, will make it... So consider this. If we use the sine value to change the x of a circle, it will go left to right smoothly. And we can prove this by using a little timer. I like to do... So I used to like to do this timer that I would call anim time, short for animation timer, because it would often be used for animations and stuff, but I recently found out that you can use... So calling time with parentheses, of course, because it's a system function. Calls a system function that returns the number of seconds since the cartridge was run. T does the same thing, it's just a shorter version. What I like to do actually is keep more like a frame counter, but you can call it T with no parentheses. It will still be green like the system syntax highlighting, but it's not going to call the function. This is actually a personal variable called T. So we'll declare it as 0. This will be like a little bit of a frame counter, and every frame will do T plus equals 1. And then let's go ahead and print T at 888 just to make it simple, and it's going up every frame. We have a frame counter. So if we were to instead, if we were to tell our circle to print at sign of T, damn, the fuck? Okay, hold on. I'm having a bit of a stupid moment, but I have magic power, so it will just take me one finger snap to figure this out. Okay, so I'm back. I forgot something. Is that sine and cosine values are based on values from 0 to 1. So since I was incrementing time by 1 every frame, it was returning the exact same value, putting it into sine every time. But if we were to instead do 0.1, or let's do 0.01, since we can actually see it, right here I'm printing the sine of t, which is the value that I'm adding to every frame. It changes. And if you look closely, it goes from -1 to 1. Oh, okay, I guess that's what it ranges from in picotron. But it's not, it's going smoothly. It's not going straight up, straight down. It's like, so that's what sine and cosine are useful for. So we are going to draw our ship at this position, and it's going left to right. So let's instead do x plus sine of t, so we can still draw it at the center just with an offset of the sine, and it's going side to side. Right now it's only returning -1 or 1, so it only moves by 1 pixel, but if we multiply this by 8, it now has a range of 16 pixels, I think, so it's going side to side. This illustrates how sine waves work. And if we were to do y plus cosine of t times 8, like we were to tell it to go wavy with the sine wave for left and right, and wavy opposite with the cosine wave for up and down, it will produce a circle actually, because they're opposites. Pretty neat stuff, useful for lots of stuff. There's crazy things that you can do with this when stacking them. I don't understand it, to be real. But something also that's important to remember is cosine is reversed in picotron, if I remember correctly. Maybe sine is reversed? I don't know. Right here it says it equals -1. Anyways, I always do minus cosine, negative cosine, and this is returning values that are actually useful to us. So we'll just keep that in mind. So this is just, an example of how it works. So now we want to draw a circle on the outside of our ship, doing the same thing. So let's sort of get stuff cleaned up a little bit here and make some functions. So functions are really your main way of keeping things organized in your code. You're able to make a little chunk of code, set it up, and run it only when you want it to run. So right here we're going to make a function for drawing the ship. We'll call it drawShip. And we'll take a parameter, we'll call s for the ship. In order to call it, we'll have to say drawShip. Right, okay, hold on, I got ahead of myself. It will take two parameters, x and y, to draw the ship at these coordinates. So to call it, we will do drawShip x, y. We'll pass those in. And now, in order to keep this understandable, we'll call these xx and yy. So whatever values are passed in for the first and second variable will be used here and here. It goes by order, so you can name them whatever you want. This is first, this is second. So when we tell it to draw, it will work the exact same. We got a circle in the middle of the screen. And if we were to replace this with like 1010, it's drawing the ship at 1010 because we're supplying coordinates. But we are going to want to organize a little bit further by organizing the variables that are used for our ship into a table of variables. And that's exactly what they're called in Lua. It's a table. It's basically a list of variables. You can put tables inside of other tables, which technically makes them two-dimensional, able to represent a grid. If you put even amount inside, that is supposed to be like the dimensions of your grid. But we just want to basically keep all of our stuff that describes our ship in one place. So of course we'll call it ship. And when declaring a table in Lua, you say ship equals brackets. And inside here you're able to put really whatever values you want. Like x and y are 32 and 32. But this is a table now. So in order to access them, this is element 1, this is element 2, because in Lua it starts at 1, 2. If you're coming from other coding languages or have some other knowledge, like from C maybe, it starts at 0, but in Lua it starts at 1, so you're going to want to get used to that. Lots of stuff in Lua is like that. So right here we can instead do ship bracket 1 close bracket, ship bracket 2 close bracket, and it's calling 32, 32. Right here we can change this to like 10, 15, and it's calling different values because we changed them. But let's say we want to be able to access them in a way that's humanly readable for us. Well, we are able to define the sort of the name of each variable, which is called a key in coding terms. It is key and value. By default, we're supplying the key of 1 and key 2. That's what the keys were assigned to for each of these variables, since we didn't give it any. But we can say bracket x equals 32. Bracket, what's that called? Comma, bracket quotation y, close bracket, equals 32. And now, we could call it like this, exact same way except with x and y, but like that's a lot of buttons. That is 4 bracket, quotation, quotation bracket, just to call something. And it's working, of course, but when using a string for a key instead of a number, you can say .x, or .variable name, .y. That's much more convenient. As well as when declaring it, you don't have to declare all the values inside of the table when first declaring it, when first calling it out and introducing the ship table. You can actually do it like this. We could do ship.x equals 32, ship.y equals 32. Kind of like how we're accessing them here, but assigning a value to them. And it will work the same. It's much more convenient. So now we've got our values in a table. And we can, for instance, just pass our ship in here. Use s right here, because just nice little shorthand that we understand. s.x, s.y. Now this will call ship whenever you use s. Even though this says s.x, it's going to use the ship.x value. So now we have 32, 32. And if you for some reason don't believe me, we can change this to 10. Now it's at 10. So that's nice and dandy at all, but we are still not any closer to drawing a moving circle around our ship. So for this we're going to need one more value. Ship.a for angle. This is going to be the value that we plug into sine and cosine. Kind of like how for our example we were incrementing the time variable by 0.01, which I'll change back to 1 now for later. We are going to be incrementing the angle value for use with sine and cosine. So let's see, left and right are 0 and 1. So we're going to delete all this stuff in here. And for the left and right, we're going to instead have ship.a, ship.a. Oops. Minus equals 1 and plus equals 1 respectively for 0 and 1. As well as, let me show you, whenever you notice that things might be getting a little cluttered in update or anywhere, it's nice to make a function. Like this one will definitely be update ship. And this will pertain to all the updating stuff that involves the ship. We can leave our time one in there because it's a more general thing, and call update ship. Let's specify the ship as a parameter so that we can call it with just s. So s.a minus and plus equals 1. So we got that dialed in, but it's not going to do anything because we're not doing anything with it. What we really want to do is draw a circle based on this angle. Alright, and we also need to make sure that it's plus 0.01. Follow me after me here and fix this mistake. So we're going to want to draw another circle. The way that we're going to do this is by getting x and y values based on sine and cosine compared to the angle and the ship's x and y. So we're going to make a local variable. You can make local variables in Lua, and what you're basically telling it is that this is a value that will only be used here in this function. No other functions are allowed to access it or know it exists. So it's useful for keeping things organized, making sure that things are not interfering with each other, and my personal favorite is being able to reuse variable names like x and y that are very high use, have could describe many different things over the course of a project. You make it local here, and then if we have like another function, update ship, we could call another function x here, as long as it's local. We could say local x equals 3, x equals whatever here. So that is why it's useful. We're going to be making local x equal, so going off of the sine and the cosine will be sine of ship.angle, and then local y will be negative cosine of ship.angle. Alright, here we'll go draw a circle at x coordinate x, y coordinate y, make it a little smaller, say radius of 2, and still 7. And it's in the top left corner, because of course I wanted to demonstrate you need to make it relative to the ship's coordinates. So plus s.x plus s.y will make it so that this is always on the ship. So good, but let's see if we print for debugging really quick. We'll do print ship.angle. It is being changed, right? Oh, okay, and the circle's moving even. Okay, so yeah, the circle's moving, but it's just in like the very center of our circle. You know, that's not very useful. And it's also offset a little bit to the point that we're going to want to add 0.5. There we go, that's aligned better. Circles are just like that in picotron. If you really think about the math of rendering a circle, the offset does not align perfectly if you have even values. But it's still in the center. We are able to fix this by multiplying the sine and the cosine values by how many pixels we want it to be away from the center. So our ship has a radius of 4, so let's try like 6. So sine and cosine times 6 plus ship x and y plus 0.5. Now we've got a little circle on the end of our ship that shows the direction it's pointing. Though by pressing the buttons I can see I did get the plus and minus wrong. We need to reverse this in order for it to go left when we press left and right when we press right. So that's pretty sweet. I'm actually going to draw with a radius of 1. Okay, cool. So now our ship is pointing somewhere, and it's actually going to be very trivial to get the ship moving now that we know how this works. So right here, we're going to want to copy this over because we're going to be doing something similar. Consider the direction that this is pointing is giving us basically the same value, same direction that we need the ship to move when pressing a button. So let's see, button number 2, forward, 3 is back. In order to get set up for this, we got to keep in mind that the ship is going to need velocity variables. We're going to need to keep track of how fast it's going in either axis, either direction, left and right, and up and down. So for this, we're going to kind of copy our x and y with velocity x and ship.velocity y. We'll set it to 0 so it's not moving at the very start. And right here, we can do s.vx plus equals x, s.vi plus equals y. Both of these will be added to when we press this, and we'll add to the velocity in the direction it's facing. Though if we just do that, it's not moving, because the velocity is not currently affecting the direction the ship goes. We actually need to say ship, or s, because we're using s here, s.x plus equals, so add to the ship.x variable its velocity variable. And let's do the same thing for the y, so it's accurate in both directions. And if we run this, holy shit, okay, I don't think we want to multiply this by 6. Oh no. Is this too big or am I doing it wrong? Okay, that's a start. Ah, yes, yes. Wait, shit. Okay, right. This was for drawing, but this one is for not. This one we actually just want to return values 0 to 1, respectively. If I recall correctly, the 0.5 won't be necessary either. Shit, what's going on? Oh wait. Ah, I'm silly. You may have noticed when I was typing this in and thought, what a dumbass. We have to do ship.y plus equals ship.vy. And now once we get all this plugged in correctly, we can actually move our ship. I have it divided by 100 because if you don't, your ship's going to go off screen real quick. He's out of this hoe. And you're not going to be able to get him back because you can't see him. So yeah, divide by 100 real quick so we can just have some fun. We've actually got a little circle moving around with trigonometry. We can point it around and I mean that's about it, but we got a ship. So in order to make the ship not fly off the edge of the screen, we're going to want it to sort of reflect it, like the edge of a pool table reflects a ball. So in order to do this, let's do some more organization and set up a function for control ship as a parameter. And this will be our controls. So we need the x and y for this. So we'll take everything except for that. This bottom part applying the velocity. Call control ship s and make sure it works is always, good to be precautionary. And then let's do as well as move ship where we are applying the velocity. So we have control ship and move ship now, and it's just the exact same thing but organized. But excuse me. I'm thinking a good place to put the reflection is with where we increment its position by its velocity here in move ship. So thinking logically, what we really want to do is do a conditional, where every frame we gotta check if the ship has went out of bounds. We gotta check if its x value has went less than 0 to be off screen, or if its x value has went more than 64, that's also off screen. Same thing with y. Since it's a square, it's the exact same thing with y. So something kind of cool about physics. This is going to be physics accurate because when something hits a wall like that and reflects, like it's called like elastic collisions or something, I don't know. It retains its velocity, but whatever direction the wall is facing, so it's like a left side wall, its x velocity, you could say in code relatively, will be reversed and will move in the opposite direction, not for both of its velocities. Y velocity is completely retained, but x velocity is reversed, and we can simulate this by multiplying it by -1, because when our ship's velocity is +1, currently goes right, and when it's -1, it currently goes left. So what we're going to want to do is if s.x is less than 0, this is a less than sign, you probably remember the alligator from high school, then s.vx multiply equal -1. So yeah, these equal things, you can do them with plus, minus, multiply, or division. Right here we're doing multiplication. So as soon as it's reached the left side, it's going to multiply its velocity by -1. Boing, it got bounced. But you look closely, it's not accounting for the radius. It bounces once it reaches the middle, which makes sense because we're checking its position variable, which is the middle. In order to account for this, we'll assign it a radius, let's see, of 4, because we're telling it to draw with a radius of 4, so ship.r equals 4. And right here, we're going to want to check if ship.x minus its radius, so that we can check for the left side of it, is less than 0. And then it will correctly bounce with the left side. So that's pretty sweet. Let's do the same thing with the right side. We can safely do else if here, because it's not going to be able to bounce on the left and the right side at the same time. It's physically impossible. The only thing we're going to want to change here is instead we're checking if it's more than 64. And in order to correctly apply the radius to that, we need to be checking its x position plus the radius to check the right side. So now if we line our ship up, we can go bouncy, and it will be simple to get it set up for the other sides. As precautionary, I like to set them up in separate statements, but you can literally just copy paste this, switch all the x's to y's, all 4 of them right here, and it's gonna work. Now we got it bouncing off the bottom and top. So this is pretty sweet. We got a controllable ship, and we can have some fun and bounce around with it. But if you try to break it and make the ship go forward only when it's going forward, and then let's point its direction upwards, up only when it's going up, you might just be able to get it fast enough to where it breaks out of bounds. Okay, it looks like, okay, well I tried. Basically my point is that it's actually important to apply the velocity as soon as it bounces, so that no bugs are able to happen where it's going so fast that it goes out of bounds and it ends up stuck on the edge, infinitely switching velocity directions forever. It's a very common bug with things like this. But I'm noticing here we're adding its velocity divided by 10, which is a little bit messy. What we're actually going to want to do here, when we add to the velocity from pressing a button, let's add the x divided by 10 and y divided by 10. We can also put it right here. Makes no difference really. But my main point is that this will work the same, and what we can do is apply the velocity as soon as it detects a bounce. So we just got to copy our velocity application here, plus equals s.bx plus equals s.by, and this will guarantee that we don't get any weird bugs. So now we have a ball who's completely constrained to this 64 by 64 dimension. He's not escaping really ever again. So now that we're able to bounce it off the walls, that is pretty cool, but it's not the most convenient thing for a pool game. Having to move your little aiming thing left and right with the left and right arrows, I can feel it's just lame already. Well, we want something more like here where we can aim with the mouse, just kick back, maybe shoot some billiards. So in order to do that, we're going to need to retrieve the mouse positions. Let's keep things real organized and make a function called update mouse, and make sure to call it every frame so that you're not confused as to why it's not doing anything. And what we're going to want to do in this function is call the picotron function mouse. And this is a function that returns values. So kind of like how saying ship.x minus ship.radius is less than 0 can return true or false. This is a system function that's able to return numbers, and it returns mouse positions. So we are able to define whatever variables we want to this. And what I like to do is make another table for the mouse, called mouse data. Because if you type mouse, it's green, and if you don't type the parentheses, it's not going to call the function. So this will be convenient. Dude, mouse equals an array, and this should not throw an error. Okay, cool. And then we can say right here, we don't have to declare them for the system to know they're a thing. We can actually, well actually just for the terms of safeness and sanity, let's do. Let me show you something. So this will be green, so we know it's sort of like a system thingy, like our time. And we're going to need x, so we'll do mouse.x, comma, mouse.y equals 0, comma 0. That's right, you can declare multiple variables in one line. It's useful for things that are similar, like x, y, really whatever you want. If we mouse over this, strawberry source tells you what these will do, so we can see it returns x, y, button, wheel x, and wheel y. So we'll do the button right here. We'll do mouse.butt, so that's fun. Mouse.butt equals 0. And then mouse.wx for wheel x, mouse.wy equals 0, 0. So we got these initialized, and now we can, in order to set the values to them, is every frame we're going to be, oh right, we need to, sorry, we need to do it in the order that they're called. Here, give me a moment. So, you can see it says returns x, y, b, wheel x, wheel y, so we need to say mouse.x, mouse.y, mouse.put, mouse.wx, mouse.wy equals mouse. So you're able to make your own functions that return things. So like you could say, for instance, function add values, and val1, val2. So we give it multiple parameters with a comma, kind of like this, and we can say like local val3 equals val1 plus val2, return val3. And then we can say like local value equals add values, 10, 15. And it will take 10 and 15, put them in here, and return it so that this equals val3. So we're basically saying value equals 10 plus 15. And we can verify this by throwing actually an error. A useful system function is the error function, where you can put a little message, say error value. Shit. Attempt to call a table value. Okay, I was wrong, so I'm sorry about this, but you're gonna have to do some copy pasting. Traditionally, for this reason, yeah, I call my mouse variables mouse data. And actually, picotron is, well, the default code editor has a find and replace type thing, so we can go ahead, put mouse in here, find, replace with mouse data, and, oh shit, mouse data. Make sure your cursor's at the right spot when you're doing this, so we've got it before everything we want to edit, down. Okay, replace. Okay. And also, I typed this in wrong. So add values, 10, 15, error, 25. If we were to do 15 plus 15, it will give us 30. Anyways, yeah, that's how you use functions with return values. So basically every frame we're getting mouse data.x such. So let's go print mouse data.x 888, and it's printing where the mouse is. And it's relative to the window, which is useful, so you don't got to do any offsetting based on window position or nothing. It does that for you. So now that we have our mouse position, how long has it been? Do I want to do this episode? Oh, okay. So it's been about an hour already, so next episode we're going to work on getting mouse controls set up so that our ship isn't so lame, but for now maybe enjoy bouncing your ship around and having some knowledge about Lua. I'll get back to this probably tomorrow or something, and we'll do some more learning, like how to move the ship with the mouse, and after that we'll be fully set up to add the balls, if I'm thinking about this correctly. So we're going to learn about the early, most complicated part of this program, which is the ball-on-ball collision, using something called dot products, some trigonometry. Hopefully I'll be able to make sense of it to you, because it's a little complicated. It had me puzzled when I first started coding. I just preferred to paste it in and hit my balls around, but it's pretty interesting. So I'll see you next time, and peace out.